Now I'm going to describe how climate varies across North Africa and the Middle East. It doesn't have as much complexity as Northern America and Sub-Saharan Africa. Why not? Because it's mostly a B climate. So we can see in North Africa, but also in the Middle East, on both the left and the right, we see a lot of red. And if we go to the key, what does red mean? Red means it's a desert. It's a B climate. Once again, we're mostly focusing in here on A, B, C, D, and E climates. In the case of this particular region, we ain't going to see D, and we ain't going to see too much E. There are some places where we do see some D climates, but that's only in the extreme upland areas, and you can see that up there in Turkey. So Turkey is, first off, the most northern place, part of this Middle East region, but it's also got a lot of highland areas. It's quite rugged, and so subsequently, that's why we see a little bit of purple there in Turkey. So there is some D climate. There is also some C climate. Where do we see some C climate? Also up there in those areas with a little bit higher elevation. But guess what? We find the Mediterranean climate region along the Mediterranean. Go figure. And we can see that in two different instances. And so you can see that in terms of Mediterranean in the Middle East map, there where we see Israel and Syria and coastal parts of Turkey along the Mediterranean, but also in the Africa map, we can see it there in North Africa, in parts there in Libya, parts there in Tunisia, parts there in Algeria and in Morocco, but essentially there on the other side of those rugged mountainous areas about the Atlas Mountains. However, what do we see overwhelmingly is a B climate. And so what's going on here is we have the high pressure that is always in this area, that subtropical high pressure equals dry. And so the Sahara Desert is so stinking dry because the subtropical high pressure is always hanging around overhead. Over in the Middle East, same true with Egypt and the Arabian Peninsula, in the Arabian Desert, is because the high pressure is always hanging around, and so it leaves behind a lot of cloudless skies, high pressure dry, no clouds, no rain, but also with that means, with no clouds, we get extremely high temperatures in a rather warm area. So this is going to be very, very hot desert in this particular area of the world. And so to sum up the climate regions before I go a little bit more into the nuances of this particular region is we do have a little bit of variety, and a lot of that variety is related to the fact we have highland areas and water bodies, but overwhelmingly we're mostly a B climate. Here we have the temperature maps for January and July. First off, some things we note. You can see the role of being along a coastline in terms of moderating temperatures. On both maps, you can kind of see how the edges of, for example, the Arabian Peninsula or the area along the Mediterranean coast, those areas along water bodies, you can see how kind of the edges are different than what we see more farther inland. In the case of the January map, in the case of the Arabian Peninsula, it has that kind of that yellow coastline going all the way around it. And then inside it's got the green. So that's the role of, in the case of January, a water body kind of keeping the nearby area a little bit warmer than it would otherwise be if it was farther inland. Same with the Mediterranean Sea. We can see kind of a green line along the coastline, but we go a little bit further south or a little bit farther inland, and we see it's blue, it's cooler. And so once again, the role of the Mediterranean Sea for kind of warming up temperatures along the coastline. And then we see the opposite there in the summertime. Now, there is an exception. That exception would be the Persian Gulf. You can see the Persian Gulf gets extremely hot during the summertime. It really doesn't do a good job of cooling the nearby areas. Why is that? It's because it's so shallow. It's a very shallow water body. And so because of that, just think about the shallow end of the pool, it doesn't take much to heat it up. And so it stays cooked cooks very, very quickly. And so it actually causes a situation where it actually increases temperatures at night because that water is retaining all that heat and holding that heat, and then it distributes it on the land overnight. Some other patterns that are clearly that we see here when we look at temperature is the role of upland areas. So we can see upland areas in terms of cooling temperatures, but we can also see a little bit of the influence of latitude. If we look at where we see Iran in both maps, we can see Iran in terms of those Zagros Mountains, and then up in Turkey, we can see the Caucasus Mountains. We can see those upland areas variations in temperature, and that variation in temperature is definitely cooler there in the winter time, but also in the summertime. That's from the elevation, the role of altitude. Now, when we compare the January and the July precipitation map, we can once again see the role of being located near a water body increases your chances of having precipitation. Kind of makes sense. If you have a nearby source of moisture, it's going to increase the chances that actually that moisture going to come onto the land. So we can see that definitely in the case in January when we look at along the Mediterranean. So what we have going on there also is the predominant pattern there is we have the mid-latitudes, kind of the northern air brings moisture onto the North Africa landmass, and so there we come across the Atlas Mountains and we can see precipitation. Same goes for the Middle East, where we can see orographic precipitation from the mid-latitudes bringing moisture there in Turkey, but also there in the Zagros Mountains in Iran. So Iran does get some precipitation in certain parts, but in other places it's quite dry. It all depends on where you are located in relationship to those mountains. I've already explained that beforehand. So for the most part here, we can see variations in temperature and precipitation related to being near a water body or having an upland feature nearby. Another thing to note is you actually find the highest temperatures in the world. Some of the highest temperatures in the world have actually been found in the Sahara Desert and the Arabian Desert. Why is it so high there? So we're talking 120s, 130s is not uncommon. So what's going on there is it's very much tropical. So we have we're very close to the equator, so we're going to get very strong, powerful incoming solar radiation from the sun. But unlike the tropical rainforest, they've got that dense cloud belt that's always up above, and so it kind of helps to prevent that incoming solar radiation from coming screaming through the atmosphere and hitting the land surface. In the case of both of these deserts, there's no clouds, and so what that does is it's all day long superheating of the surface from that incoming solar radiation that has nothing blocking its way, and so that's why temperatures can actually get up in this particular area of the world higher than any other place we'll find.